Hey guys, welcome back. I'm here to do a video finally on chemistry. I had some requests to come in, and some people, I'm assuming students from wherever they were from, wanted me to do some problems involving the calculation of pH. And we're going to get started with that. Alright, so here we have a problem that says calculate the pH of a solution of 0.030 molar HCl. All right, in order to calculate pH, we need to have the pH formula. So let me write that down for you. pH, this is the formula for pH. pH equals the negative log of the hydrogen ion concentration. So, what we need to do is we need to look at the formula of the acid or the base that we are given. Well, if you notice here, we are given an acid. That's great. If we're given an acid, this isn't so bad. Alright, so what we're going to do here is we're going to figure out the ratio of hydrogens to chlorine, but really we're finding out the ratio of the hydrogen ions to the chloride ions. Well, that ratio of H to Cl is 1 to 1. And the reason why it's 1 to 1 is we've got one hydrogen, we've got one chlorine. Alright, now once we figure this out, all that we care about is this. Now, if this number is 1, we don't have to do anything special to our molarity, our concentration. Okay, so basically, if this is a 1, then this number here, this 0.030 molar, will be used in this formula. Okay, so all we got to do here is write down pH equals the negative log of the hydrogen ion concentration. Since it's 1, then it's just this number. Okay, so we're going to write inside here for H plus, we're going to write 0.030, and we'll go ahead and finish closing that in brackets. Now you'll definitely need a calculator to finish this problem out, so make sure you have your calculator handy. Here's mine. Okay, now I need to punch this in. I'm just going to leave it over here so it doesn't cover me up. So here we go. We're going to turn the calculator on, and if you're not used to this, I'll show you. The negative sign is down here, so you'll press negative. And next, you need to find the log button, and on the TI-84 Plus, it's right next to the number 7. So just click on log, and then 0.030, and we'll close the parentheses. Okay, after that, we'll press enter, and we end up getting this number. So let me write that down. So this ends up being a pH of, let me bring that back up, 1.522 878745. Now, those of you that are great with sig figs, you're probably saying, way too many digits. Yeah, you're probably right. Now, usually, most of the devices that will measure pH will only go out to 2 decimal places. So, depending upon what your professor or your teacher wants you to do here, if they just want you to go by the number of sig figs, then so be it. Here, we've got 2 sig figs, so it's kind of hard to argue that our pH can only be 2 sig figs. So the pH here will be 1.5 if you're keeping 2 sig figs. This will be your answer. Now, if your instructor specifically told you that they wanted you to go out to the nearest hundredths place, then your pH would just be 1.52. So anyway, that's how you calculate the pH of a solution given the molarity, or you can say concentration, of the acid when it's 1 to 1. Now let's look at a case where the ratio is not 1 to 1, where it's possibly 2 to 1 or 2 to 3. Okay, so let's look at that. All right, in this second problem, we're going to go on down. In the second problem, we have calculate the pH of a solution of, and once again, I've given us the same molarity, the same concentration, but this time I've given it in the form of this acid, which is H2SO4, sulfuric acid. So let's see how you work this problem. Well, since they ask you to calculate the pH, you're going to need this formula. So we have pH of a solution, so equals the negative log of the hydrogen ion concentration. Okay. Now let's look at this formula. Now, looking here, how many hydrogens do you see? Now, if you said 2, you're right. So far as the ratio goes, we know that we've got 2 hydrogens. Okay. Now let's look at the other ion. Okay, because remember we're doing this for ions. Now this is a group of ions. This is a polyatomic ion, SO4, which is sulfate. Now, if you look at sulfate, you'll find out that it's got a charge of -2. But how many SO4s are here? Well, there's only one. So our ratio of hydrogen ions to sulfate ions is 2 to 1. So we've got 2 hydrogens. All right, that's important. Here is why it's important. This concentration that we have here then, okay, cannot be just 0.030. The reason for that is we've got twice the amount of hydrogen ions versus the number of sulfate ions. So we have to double that number. So maybe somewhere off to the side, if you want to, you can double it. But I always felt like that could possibly cause you to make a mistake. So I encourage my students to just include it in their calculations. So watch. Okay, you have the pH equals the negative log of the hydrogen ion concentration. Now we've got 2 hydrogen ions here, not just one, but 2. So we need to take that 2, we need to multiply it into the original molarity concentration that was given to us, which was 0.030 molar, or you can say concentration. Okay, so we're going to go ahead and close that in brackets. And remember, the reason why this 2 is here is because we've got 2 hydrogens. Okay, so earlier I didn't show the 1 because it honestly is not necessary, so I didn't show it. Alright, so let's go ahead and punch this into the calculator. Okay. Alright, so here's our calculator. We'll turn it on, make sure everything's cleared out of the way. Alright, we have the negative log of 2 times 0.030. Close those parentheses. Now press enter. And this time we get a pH of, let's write all this down. pH equals, sorry I don't remember the number, 1.221 84 87 5. Let's compare, make sure I wrote all those down right. 1.22184.875. Now, of course, according to the number of sig figs, way too many. We only need 2 sig figs, so our pH here is going to be a pH of 1.2. And just as I said before, just listen to your professor in class and or your instructor or teacher and use the number of sig figs or to the tenths, to the hundredths, you know, however far they want you to go out. But 2 sig figs is what we're doing here. Okay? Alright, so this is how you calculate the pH of a solution when you're dealing with an acid. And if you got more than just one hydrogen ion. So anyway, well, I hope this was helpful as far as acids go, because we've only got two more problems to do. We're going to do two bases this time. They require a little bit more work. Okay. All right, so let's go ahead and just do a flashback real quick. Notice here we got a concentration of, we got a pH of 1.5, and down here we got a pH of 1.2. Now, between these two acids, this is just a question. Between these two acids, which one is the stronger? I shouldn't say stronger. Which one is the, well, good. Which one of these is the more acidic acid? Is it the 1.5 or is it the 1.2? If you're going by the pH, remember, the lower the pH, the stronger the acid. And the larger the pH, the stronger the base if you're past 7. Okay? So, remember the acids are between 1 and less than 7, and bases are above 7 up to 14. Okay? And 7 is neutral. All right, let's look at a base now. Okay. All right, what is the pH of a solution of this base? Okay, well, just before, let's identify. This is our concentration. Okay, right here. This is our concentration. And we notice this time we have a base. How did I know that this was a base, you're probably asking? Well, notice that this thing ends in OH. Okay. Some people say, oh, it ends in H, that's why it's a base. I guess you can get away with that for the most part. But if it's got OH, then it's more than likely basic. Sorry, I had to get something to drink. All right. So let's go ahead and talk about these ratios again, okay? Now, how many K's do you see here? Well, I only see one potassium ion. So, of the potassium ions, we only have one, okay? So far, we have a ratio of 1 to something. Now, look here. How many OH, which are hydroxides, do you see? How many hydroxide ions? Well, if you said you only see one, you're right. It's 1. The ratio is 1 to 1. Yay! All right. Now remember, let's look at that formula that we need for pH. The formula that we need for pH is pH equals the negative log of the hydrogen ion concentration. Well, we're kind of running a problem right here. We don't have a hydrogen ion. We have a hydroxide ion. All right. When this happens, there's a couple of different ways you can work this problem. I'm going to show you probably what's viewed as the traditional way of working this problem. So we kind of got a problem. We can not continue the calculation because we don't know the hydrogen ion concentration. But we do know the hydroxide ion concentration. And since we're dealing with a base, we got to use another formula. Okay? Let me give that one to you now. All right. This is true. If you take all of the hydrogen ion concentration and you take all of the hydroxide ion concentration, so that means the concentration of all that is, say, acidic and all that is basic, they should have a total of 1 times 10 to the negative 14. And the reason why it's a negative 14 is really this. The 14 is key in pH. In other words, that's the highest number that you can have. Now, what we're going to do is we're going to plug this number in, the 0.050 in for the hydroxide. Okay? So, what we have here then is the concentration of the hydrogen ion times the concentration of the hydroxide, which is 0.050. So let's write that here. 0.050 0.050. Now, if you remember, I only have one hydroxide. Okay, since I only have one here, I don't have to worry about using a multiplier here. Okay, I'm going to go ahead and set this equal to the 1 times 10 to the negative 14. Now remember, I'm kind of like working on two different sides here. Okay, all right, so there's that. Now, let's solve this for the hydrogen ion so we can get the hydrogen ion concentration. So, those of you that are great at algebra, all we need to do is divide both sides by 0.050. Well, if you don't understand why we're dividing both sides by 0.050, it's because this reads the hydrogen ion concentration times, just look at these brackets as, parentheses. Hydrogen ion concentration times the concentration of the hydroxide ion. So we got to divide both sides by 0.05. When we do that, if you don't like that, then we're just going to move this to the bottom down here. Okay, so that's going to be equal to 1 times 10 to the negative 14. Whoops, I about wrote just 4 to the negative 14 divided by 0.050. All right, there's that. Now let's use a calculator to get this hydrogen ion concentration, okay? All right, so let's do that. All right, we're going to pull our calculator back up. We'll move it over just a little bit so we can see this. So we have 1 times 10 to the negative 14. Remember, you can type 1, then hit second, and the button above the 7, which is this EE, which means times 10 to some power. We're going to go ahead and type in negative 14 there, and then we'll press divide because all that's in our numerator. Divided by 0.050. Press enter. We get that number right there. All right, so let's write that down. We get 2 times 10 to the negative 13. All right, let's make sure that's correct. We get 2 times 10 to the negative 13. All right, so I guess technically I should write 2.0 there for 2 sig figs because of the 0.050 being 2 sig figs. But I know I had to have 2 sig figs, so I'm just going to go ahead and finish the problem. All right, we now have our hydrogen ion concentration. Okay, now we're going to use this in this formula. Okay, so we have the pH equal to the negative log of the number that we just calculated for the hydrogen ion concentration, which is 2 times 10 to the negative 13. All right, so let's go ahead and punch that into the handy-dandy cheater later. I know it's been a while since y'all got to hear me. It's been a while since y'all got to hear me say cheater later. All right, so we have negative log. Oh, it's hard to see the screen with the microphone in my way. But still, I'm glad that I'm not wearing my headset for this. Alright, so we have the negative log of 2 times 10 to the negative, let me press negative 13. Alright, double check everything. We've got negative log, we've got 2 times 10 to the negative 13. So let's go ahead and punch that in. That's going to give us that number. So let's write that down. We get a pH. I should just tell that to stay on top. pH equals 12.6987. Oh, almost 897. All right, let's leave that up. So 12.697. All right. Now we only need 2 sig figs, but this is where I always get frustrated with sig figs. Even though it's only 2 sig figs, this is 12 point. Now all the other pHs that we calculated all have at least went out to one number behind the decimal. So this is where sig figs have even frustrated me. And I think it's awful to go ahead and just write down a pH of 13 when that's not accurate enough. So pH is equal to 12.7. And a lot of times I'll just tell my students, go ahead and write down the entire number first. Then when you're going to do your sig figs, write that down. Okay? Unless I specifically tell you I want 3 sig figs, then you give me 3 sig figs. This is one where it would drive me crazy to not tell the students that it's supposed to be 3 sig figs, or only because I made a mistake and didn't add an extra 0 here to make sure we got 3 sig figs. So either way, I probably would just put in the problems 3 sig figs, just to make sure that everyone, got what I wanted them to get as far as sig figs go. All right, so there's that. Okay, so we're done with this problem. Now let's look at our last problem of the night on pH, and it's going to be for another base, as you can see down here. All right. Oh, I hope everybody was done looking at that. So, all right. If not, pause it, rewind. Now fast forward. All right, let's look at the last problem for tonight. We've got the following. We have the pH. Sorry, I'm moving the screen up. What is the pH of a solution of 0.050 molarity? All right, well, we know that we have a base, so let's do that. Okay, I'm going to write base up here. All right, since this is a base, I need to figure out my ratios. Okay, we have calcium ion, and how many calcium ions do we have? Just one, that's all we have. Now, how many hydroxide ions do we have? If you said 2, you're right, and that number is important now. Now remember, if we're calculating pH, pH is equal to the negative log of the hydrogen ion concentration. And once again, if you pointed out that we don't know the hydrogen ion concentration, you are correct. We don't. We have to calculate that. All right. Now look. Pay attention to the concentration here. Okay. All right. Now remember, we have twice as many hydroxide ions as we do calcium ions. So we need to double this number. Okay. All right. With that being said, let's use another formula because we need the hydrogen ion concentration. So, the hydrogen ion concentration times the hydroxide ion concentration is equal to 1 times 10 to the negative 14. Now, let's go ahead and plug in what we know here. We know we are looking for the hydrogen ion concentration. We also know that we have 2 hydroxide ions, and we know that the concentration of the hydroxide ion is 2 times the original concentration value given in the problem, which is 2 times 0.50. Close parentheses and then close our bracket. Equals 1 times 10 to the negative 14. Now, once again, let me tell you why I like to have my students to do this, is if they write the numbers beside this, they know they have accounted for the number of ions of the hydroxide in the ratio. They know that they have a 2, they know they should see a 2 here. If they have just a 1 here for OH, they know they shouldn't have any number at all, they should have the original number. Alright, now let's do some algebra. We need to get the hydrogen ion concentration away and by itself. So we have the hydrogen ion concentration equaling 1 times 10 to the negative 14th divided by the concentration of 2 times 0.050, close parentheses, and close your bracket. Now, you definitely want to make sure you're careful down here, okay? Especially when you're punching it into the calculator. So let's go ahead and write this down. So we have H plus for our concentration equals, now we need to use the calculator. So here we go. Now, if you want to use parentheses here because you're paranoid, I totally understand. I would be too. All right, so let's go ahead and clear this out. Start from scratch. We have 1 times 10. That's the button above the second, the button above the 7. That E means times 10 to a power. They said negative 14, so we type in negative 14. Divided by, and you might want to use parentheses here. Parentheses. 2 times, that's all I'm going to say, 0.050. Close those parentheses. Now what that does is that makes sure that those two numbers that are being multiplied together, which are these two right here, stay in the denominator because I only have one set of parentheses in my denominator. Alright, so now I'm going to press enter. I get that number. Alright, so let's write that down. That's our hydrogen ion concentration, which is 1 times 10 to the negative 13. Alright, so let's go ahead and finish this up now. We have a hydrogen ion concentration, so let's plug that into our formula for pH. So we have pH equals the negative log of the hydrogen ion concentration. So that's pH equals the negative log of 1 times 10 to the negative 13. Close bracket. Alright, let's punch that into our handy dandy cheetalator. Clear. Alright, so we have the following. We have negative log 1 times 10, so that's second, comma, to the negative 13. Then we'll close those parentheses, and then we'll press enter. And lo and behold, we get 13. Okay, so that gives us a pH of exactly 13 according to the calculator. And that's correct, by the way. Alright, now, like I said, if you were measuring this with a digital device, you would get more than just exactly 13. You probably get 13.0. So, like I said, go according to whatever your teacher tells you, and your professor or teacher, or I always said that, professor or instructor. If they want you to go out to one decimal place, go to one decimal place. That's fine. If you want to go out to just 2 sig figs, that's fine. So 2 sig figs would be pH equals 13. 1 decimal place, or 3 sig figs in this case, would be 13.0. So anyway, guys, I hope that this was helpful as far as calculating the pH, given a solution, given a molarity of a basic solution or an acidic solution. So, all right, guys. If you have any more questions, just send me a message or make some comments, and please like and subscribe. All right, guys. You have a good one. Have a good night.